You were taught that time is a line. It has a beginning, the moment of the Big Bang, about 13.8 billion years ago, and it has an end, a cold and final darkness, almost unimaginably far ahead. And these 2 points sit at opposite ends of everything, as different as hot and cold, as full and empty, as loud and silent. But here is what they left out. Both of those ends are places where our physics quietly breaks down, where clocks stop meaning anything, and rulers have nothing left to measure. And a small group of serious physicists has begun to suspect something that sounds impossible, that the cold, empty end of the universe and the hot, dense beginning are not 2 places at all, but one, joined so smoothly that the death of everything is, in the same breath, the birth of everything, that the universe ends exactly where it began. Get comfortable, hit subscribe if you're new here, because by the end of this, the straight line of time you have carried your whole life is going to quietly bend into a circle. Now, let's slowly ease into this. Part 1. The line you were handed. Somewhere very early, without anyone sitting you down to teach it, you were handed a picture of time, and the picture was a line. It had a beginning on the left, a moment when everything switched on, and it ran to the right, through every day you have ever lived, towards some far edge where it would presumably switch off again. You did not choose this picture. It arrived the way the floor arrives under your feet, as a thing too obvious to question, and you have carried it ever since. Tonight, I want to take that line out of your hands very gently, turn it over, and show you that its 2 ends may not be where you think they are. They may not even be 2. Consider how completely the line shapes the way you think about the cosmos. When you imagine the history of the universe, you almost certainly imagine it stretched out from left to right. On the far left, there is the beginning, the moment people call the Big Bang, about 13.8 billion years ago, when the universe was unimaginably hot and dense and small. From there, the line runs rightward through the slow construction of everything, the first light, the first stars, the first galaxies, the long, quiet middle in which planets formed and oceans gathered, and you eventually opened your eyes. And then the line keeps going, past you, past everything you will ever see, toward a far end that physics has a name for as well, a cold and dark and final state that is usually called the heat death, beginning on one side, ending on the other, and all of cosmic history laid out in between like towns along a single straight highway. This picture feels not just natural but unavoidable, and it is worth pausing to feel why. You live your own life as a line. You were born, you are here, you will end, and the order never reverses. Morning never follows evening backward. The cup that falls and shatters never gathers itself up off the floor and leaps back into your hand. Everything in your direct experience runs one way, from a start you did not see, toward a finish you will not watch, and so it is the most reasonable thing in the world to assume the universe does the same, only on a grander scale and over a longer span. The line is not a foolish idea. It is the honest generalization of every moment you have ever lived. And the 2 ends of that line seem about as different as 2 things can be. The beginning was hot, the end will be cold. The beginning was crowded into a space smaller than anything, with all of energy packed together. The end will be spread so thin that whole regions of space will hold almost nothing at all. The beginning was a place of furious activity, of creation, of everything switching on at once. The end will be a place of perfect quiet, where the last fires have gone out and nothing is left to happen. If you wanted to design 2 states to stand at opposite ends of a story, you could hardly do better than these. One is the loudest possible first note. The other is the longest possible silence after the music stops. So the line has its 2 ends, and the 2 ends could not look less alike, and the whole arrangement is so familiar that you have probably never once held it up to the light and asked whether it is true. That is exactly what I want to do with you tonight, slowly and without any rush, because the question hiding inside this comfortable picture is one of the strangest in all of physics. The question is this: what if the far right end of the line and the far left end of the line are not two different places at all? What if the cold, dark final silence and the hot, bright opening note are, in some real and physical sense, the same thing? What if the universe, for all its apparent travel from one end to the other, ends exactly where it began? I know how that sounds the first time you hear it. It sounds like a riddle, or a trick of words, or the kind of thing someone says to seem profound without meaning anything. But it is none of those. It is a serious proposal, taken seriously by serious physicists, and it comes in several forms, each with its own mathematics and its own way of making the two ends of the line touch. By the end of our time together tonight, the line you were handed so long ago is going to look different to you. It may not look like a line at all. It may have quietly closed into a circle while you were not watching, and the most unsettling part is that, from where you stand on it, you would never be able to tell. There is even a name, in physics, for the one-wayness you feel so strongly. It is called the arrow of time, and it points stubbornly in a single direction, from the past toward the future, and never the other way. You can see its signature everywhere around you. Heat always flows from the warm thing to the cool thing, never back. Order always slides toward disorder, the sandcastle into the sand, the ice cube into the puddle, the tidy room into the mess, and never the reverse on its own. Physicists tie this one-way slide to a quantity called entropy, a measure of disorder that, in any closed system, only ever grows as time moves forward. That steady growth is, as far as we can tell, the truest reason the future feels different from the past. It is the quiet engine underneath your certainty that time is a line running one way only, and here is what makes the line feel airtight. Entropy was extraordinarily low at the beginning, in that hot, dense, early state, and it grows larger and larger toward the cold, spread-out end. So the arrow of time seems to confirm the whole linear picture perfectly. The beginning was the orderly tip of the line, the ending will be the disorderly one, and the arrow flies cleanly from the first to the second, never doubling back on itself. So the line is not merely a habit you picked up as a child, it appears to be stitched into one of the most dependable laws we have. This is exactly why what follows will feel so disorienting, because we are not going to challenge the line with a vague feeling or a passing mood. We are going to challenge it using the very physics that seems to pin it most firmly in place, and watch the two ends that this arrow holds so far apart begin, quietly, to lean toward each other. Before we can bend the line, though, we have to look honestly at its two ends, because the first crack in the comfortable picture appears the moment you try to find exactly where the line begins and exactly where it stops. You will discover that both ends are stranger and softer than you were led to believe. Neither one is a clean edge. Neither one is a wall you could walk up to and touch. And that softness, that refusal of either end to be a real boundary, is the first hint that the line might be doing something other than ending. Part 2. The trouble with both ends. Let us walk to the left end of the line first, all the way back to the beginning, and try to stand exactly on the moment where everything started. The trouble is that you cannot. As you travel backward in time toward the Big Bang, the universe grows hotter and denser and smaller, and the equations that describe it keep working, keep giving sensible answers, right up until the very last sliver of the journey. And then, at the final instant, the moment you actually wanted to reach, the equations stop giving answers at all. They return infinities. The density becomes infinite. The temperature becomes infinite. The curvature of space becomes infinite. And an infinity in physics is not a measurement. It is a flare sent up to tell you that your theory has reached the edge of what it can describe. This place is called the singularity, and it is important to understand what that word really means, because it is almost always misunderstood. The singularity is not a tiny hard pellet sitting at the start of time, a cosmic seed you could in principle hold. The singularity is the name for the precise spot where our best theory of space and time, Einstein's general relativity, breaks down and admits it cannot describe what is happening. The beginning of the line, the very thing you reached for, is not a clean starting point. It is a question mark. It is the place where the map simply stops being a map and dissolves into white paper. We can describe the universe a tiny fraction of a second after the beginning with extraordinary precision. The beginning itself, the actual left edge of the line, hides behind a veil that our current physics cannot lift. Now hold that thought and walk all the way to the other end. Travel forward in time, past the death of the sun, past the slow burning out of all the stars, into a future so distant that the numbers stop meaning anything to a human mind. The universe is expanding, and that expansion is speeding up, so over enormous spans of time, everything spreads farther and farther apart. The stars exhaust their fuel and go dark. The galaxies drift beyond one another's reach. Matter itself, over time, scales that dwarf the present age of the cosmos, many times over, slowly comes apart. Even the black holes, the longest-lived structures of all, eventually evaporate away into faint radiation. And what is left, at the far right end of the line, is a cold and nearly empty space, stretched thin, holding a dilute haze of light, and almost nothing else, with no events left to happen, and nothing left to mark the passing of time. Here is the first quiet surprise. The far end of the line is also not a clean edge. It is not a wall where time hits a stop and halts. It is a state that simply goes on, emptier and quieter, with no clock anywhere in it to say how long it has lasted or whether it has lasted at all. The beginning was a place where our description of time broke down into infinities. The end is a place where time loses its meaning for the opposite reason, because there is nothing left whose changes could measure it. One end fails because everything is crammed into a single point. The other end fails because everything is spread into a featureless nothing. But notice what they have in common. At both ends of the line, the ordinary idea of time stops working. That shared failure is the first thing that should make you curious. We started by saying the two ends of the line could not be more different, the hot, crowded beginning and the cold, empty end, and on the surface that is true. But underneath the surface, both ends are doing the same thing. Both are places where our clocks give out, where the smooth machinery of before and after seizes up, where the very concepts we use to talk about a sequence of moments stop applying. If you were looking for 2 points on a line that secretly belong together, you could hardly find a better clue than this. The two ends that look most opposite are the two places where the line stops behaving like a line. I want to be careful and honest here, because it would be easy to oversell this. The fact that both ends are strange does not by itself prove they are the same. Plenty of things are strange in different ways without being identical. A crowded room and an empty desert are both hard to think of as ordinary, but they are not the same place. So the shared breakdown of time at both ends is a hint, not a proof. It is the loose thread that makes you want to keep pulling, the first sign that the comfortable line might have more give in it than you assumed. The real work, the work of actually bringing the two ends together, comes later, and it is more beautiful and more precise than this first hint can suggest. It is worth dwelling on just how similar the two failures really are, because the resemblance is easy to miss when the surfaces look so different. At the beginning, our description of gravity, general relativity, collides with the world of the very small, the quantum world, and the two refuse to work together. The infinities at the singularity are really a sign that we are trying to describe something tiny and immensely energetic with a theory built for the large and smooth, and it simply does not fit. Physicists have a name for the missing theory that would describe that regime, quantum gravity, and the honest truth is that we do not yet have it in finished form. So the left end of the line is not merely unknown, it is a place where two of our greatest theories meet and break each other, and we are still waiting for the more fundamental theory that could tell us what is truly there. The right end fails in a way that feels gentler, but is just as complete. Out in that cold and emptying future, there are eventually no processes left to count, no reactions, no orbits, no ticking of any kind, and time without anything happening is a strange and hollow thing. We measure time by change, by one state giving way to the next, and where there is no change, there is, in a real sense, nothing for time to be. So the far end of the line does not stop at a wall, it thins out until the idea of duration has nothing left to hold on to, the way a sound fades, not by hitting silence suddenly, but by growing too faint to register. One end is undone by too much packed into too little. The other is undone by too little spread across too much. And both, in their opposite ways, are places where our ordinary sense of a ticking, ordered timeline simply has nowhere to stand. But before we get to the modern physics that tries to join the ends, I want to take you somewhere unexpected, because the idea that time might be a circle rather than a line is not new. It is not something physicists invented in the last few decades. It is, in fact, one of the oldest ideas human beings have ever had about the shape of existence, older than telescopes, older than writing in some forms, carried in images and stories long before anyone could put a single equation to it. When the mathematics finally arrived, it did not arrive as a stranger. It arrived as the return of something humans had been quietly suspecting for thousands of years. Part 3. The oldest idea. Long before anyone measured the age of the universe, long before the word galaxy meant anything, human beings looked at the world around them and noticed that it ran in circles. The sun rose, crossed the sky, set, and rose again. The moon swelled to full, shrank to nothing, and swelled again. The seasons turned from cold to warm to cold without end, and the crops died back into the ground and came up green again in the spring. Everywhere a person looked, time seemed to curve back on itself. Nothing in the ordinary rhythm of life behaved like a straight line running off toward a final edge. Things came around, things returned, and so it was the most natural thing in the world for early people to imagine that the cosmos itself, the whole of existence, must also turn in a great circle, ending where it began and beginning again where it ended. You can see this intuition preserved in one of the oldest symbols human beings have left us, a symbol that appears independently in many separate cultures across the ancient world. It is the image of a serpent curled into a ring, swallowing its own tail. The figure is usually called the Ouroboros, and it is worth sitting with for a moment because it is a remarkably precise piece of thinking dressed up as a picture. A snake that swallows its own tail has no free end. You cannot point to where it starts, because its mouth is at its end, and its end is at its mouth. The beginning and the conclusion are the same place, fused into a single point, and the whole figure turns endlessly through itself, with no edge anywhere to be found. Thousands of years before anyone could write down a field equation, someone looked at the world, felt that time curved back on itself, and drew exactly that. The same instinct shows up again and again across human history, in culture after culture, in the form of world ages that turn and repeat. Many ancient cosmologies imagined not a single creation followed by a single ending, but a wheel of immense ages, each one running its course and giving way to the next, the cosmos dissolving and reforming over and over across spans of time so long they were measured in the lifetimes of gods. The details differ enormously from one tradition to another, and I do not want to flatten them or pretend they were all saying the same thing. But the underlying shape recurs with stubborn persistence. Time as a wheel, existence as something that comes around. An end that is not really an end, but a hinge, a turning point where the whole thing begins again. For a long stretch of more recent history, this circular picture fell out of favour, at least in the parts of the world whose thinking came to dominate modern science. The line won. Time was reimagined as an arrow with a single beginning and a single end, running once, never repeating, and that linear picture turned out to be enormously powerful and productive. But the circle never fully disappeared, and in the late 19th century it returned in one of its most haunting forms, not from a priest or a poet, but from a philosopher, in the shape of a thought experiment that has unsettled people ever since. The philosopher was Friedrich Nietzsche, and the idea was what he called eternal recurrence. Nietzsche asked his readers to imagine a possibility, and he framed it almost as a confrontation. Imagine that this life, the exact life you are living right now, down to its smallest and most trivial details, has already happened an infinite number of times before, and will happen an infinite number of times again. Not a similar life. Not a life with the same general shape. This exact life, the same choices, the same pains, the same small joys, the same moment you are having right now as you listen, all of it returning over and over forever, with nothing added and nothing removed. He was not, in that moment, making a scientific claim about the physical universe. He was asking a question about how you would feel, how you would have to live if the line was secretly a circle and you were destined to ride it again and again without end. What I find remarkable is how close Nietzsche's thought experiment sits to ideas that would arrive in physics much later, ideas built not on intuition or feeling, but on equations and theorems. He could not have known, writing when he did, that there are real mathematical results which suggest that a finite physical system, given enough time, must return arbitrarily close to any state it has been in before. He was working from philosophy and from a kind of stubborn, imaginative courage, following the circle wherever it led. But the shape he arrived at, a cosmos that comes around, a life or a universe destined to return to its own starting conditions, is the very shape that modern cosmology would stumble into from a completely different direction, carrying completely different tools. It is worth pausing on how seriously these older cultures took the scale of their cycles, because the spans they imagined were not small. In several traditions, the great ages were measured in enormous stretches, cycles nested inside larger cycles, world ages turning within still greater world ages, reaching durations that strain the mind even by modern standards. These were not people casually assuming the world restarted every spring. They were imagining cosmic rhythms of staggering length, dissolutions and renewals, separated by spans they could barely name, and they placed a single human life as a brief moment inside one turn of an immense wheel. The particular numbers and stories varied widely from culture to culture, and I do not want to collapse genuinely different traditions into one tidy picture. But the shared instinct that existence as a whole breathes in and out across enormous cycles, rather than running once and stopping, was widespread and durable in a way that should give us pause. The reasons the straight line eventually displaced the circle in scientific thinking are real and worth respecting. A universe that runs once, from a definite beginning toward a definite future, fits naturally with the discovery that the cosmos is expanding and cooling, with the one-way arrow of growing disorder, with a history that seems to go somewhere rather than merely repeat. The line earned its place. It was not a step backward, but a genuine advance, and it remains the working picture for almost everything physicists do today. What makes our moment so curious is that the line, pushed hard enough at its two ends, has begun to hand the circle back to us, not as a relic of older thinking, but as a consequence of the newest. The wheel is returning through the front door of mathematics, carrying credentials the ancients never had, and that is a far stranger thing than if the circle had simply never left. This is the part I want you to hold on to as we move from the old images into the new mathematics. The idea that the universe ends where it began is not a strange modern invention dropped on us by physicists who ran out of ordinary explanations. It is one of the oldest things human beings have ever thought. The snake swallowing its tail, the wheel of ages, the eternal return, an intuition so persistent that it shows up in culture after culture, separated by oceans and centuries. What changed in the last few decades is not the idea. What changed is that the idea began, unexpectedly, to fall out of the equations, to appear as a consequence of taking our best physics seriously, rather than as a feeling laid on top of it. When the loop returned to us through mathematics, it returned as something we had been drawing all along. And to see how it falls out of the equations, we first have to be much more careful about what we even mean when we say two things are the same. Part 4. What the same could mean. When we say the universe might end where it began, everything depends on what we mean by the small word same, and this is where most casual talk about cyclic time quietly falls apart. People hear that the cosmos might be a loop, and they immediately picture one specific thing, usually the most dramatic thing, and then they argue about whether that specific thing is plausible without noticing that there are several completely different ideas wearing the same costume. So before we go any further, I want to slow all the way down and lay out exactly what kinds of sameness we could be talking about, because they are not interchangeable, and the differences between them are the difference between a tidy curiosity and a genuine vertigo. The first kind of sameness is the one most people imagine first, and it is the most literal. Call it the exact repeat. In this version, the universe runs its full course, reaches its end, and then begins again with the very same events in the very same order, so that everything that has ever happened happens again, identically, forever. Every star forms in the same place. Every planet cools the same way. You are born again, live the same life, have this same moment again, and none of it varies by even the smallest detail. This is the version Nietzsche reached for, the eternal recurrence, and it is the one that carries the heaviest emotional charge, because it says not just that the universe returns, but that you return, unchanged, on an endless wheel. The second kind of sameness is stranger and quieter, and it is more about geometry than about events. Call it the closed circle. In this version, it is not that history repeats, but that the timeline itself bends around and connects, so that the very last moment of the universe and the very first moment are literally the same single point, the way the snake's mouth and tail are the same place on the ring. On this picture, there is no second run and no repetition, because there is only one circle, travelled once, but a circle has no starting point and no ending point anywhere on it. You could not say where it begins, because every point on a circle is just a point with more circle on either side. The beginning and the end would be the same moment, not because the story plays twice, but because the story curves back and touches itself. The third kind of sameness is the one that turns out to matter most in modern physics, and it is the most subtle of the three. Call it the generative loop. In this version, the end state of the universe does not repeat the beginning and is not literally the same point as the beginning, but it physically gives rise to a new beginning. The end becomes the seed of a fresh start, and that fresh start runs its own course, which produces its own end, which seeds another start, on and on. The cycles need not be identical to one another. Nothing has to repeat. What loops is not the events, but the process. The way the finish of one chapter is precisely the raw material for the opening of the next. This is the version that falls out of the strongest physical models, and it is worth noticing that it is neither the eerie exact repeat nor the pure closed circle. It is something in between, and arguably stranger than either. These three are genuinely different, and you can feel the difference if you ask what each one would mean for you personally. In the exact repeat, you live this life again, identically without end. In the closed circle, there is only one of you on one timeline, but that timeline has no real first or last moment. So your birth and the universe's death are points on the same unbroken ring. In the generative loop, you do not come back at all, but the matter and energy that make you, the very stuff of this cosmos, becomes the substance of universes that come after, none of which will contain you, all of which will descend from the ending of the world that does. 3 different kinds of return, 3 different fates, all hiding inside the simple phrase, ends where it began. Now let me try to make the closed circle, the second kind, something you can feel rather than merely follow, because it is the hardest of the 3 to picture and the one that most rewards a moment of imagination. Imagine you set out walking along a road, and the road is time itself, running forward into the future. You walk the way you always walk, never turning around, never doubling back, always facing forward, always moving from each moment into the next one ahead of it. The road feels perfectly straight beneath your feet. It runs to the horizon ahead of you, dead ahead, with no visible bend in it anywhere. You walk for a long while, through the whole history of a universe, past stars being born and dying, past the long cooling, past the last light fading, always forward, always straight. And then, without ever once feeling the road curve, without ever turning, you arrive at a place you recognize. You are standing exactly where you started, at the very first moment, the road behind you somehow having delivered you to its own beginning. The road was never straight. It was a circle so enormous that its curve was too gentle to feel, bending by an amount too small to notice with every step, until the small bends added up to a full return. You walked forward the entire time. You never reversed. And forward, on a circle, eventually means home. That is the closed circle, and the thing that makes it dizzying is that nowhere along the walk could you have detected the bend. At every step, the road ahead looked straight. The future looked like an open line, running off to a distant edge, and the idea that you were curving back toward your own starting point would have seemed absurd. This is the first place where you should feel the ground shift under the comfortable line you were handed. A circle, if it is large enough, is locally indistinguishable from a line. Stand anywhere on a circle and look at the small stretch near your feet, and it looks straight. You would need to step outside it, to rise above it, and see the whole shape at once, to know it was a circle. And when it comes to time, you cannot step outside. You are always somewhere on the road, always seeing only the straight-looking stretch near your own moment, which means that even if time were a closed circle, your experience of it would be exactly the experience you are having right now. The line and the circle, from the inside, feel the same. Most popular talk about a cyclic universe quietly slides between these 3 meanings without noticing, and the confusion matters because it changes what is actually being claimed. Someone hears that the cosmos might be a loop and pictures themselves living this exact life again, the eerie exact repeat, and then they either thrill to it or recoil from it, all without realizing that the leading physical models are not saying that at all. When a physicist says the universe is cyclic, they usually mean the generative loop, in which the end of one cosmos produces a fresh new one that need not resemble it in any detail. The stars would be different. The galaxies would form in different places. There would be no second you, no repeat of this room or this moment, only the same process, running again, with entirely new contents. That is a profoundly different claim from the eternal return, and mistaking one for the other turns a careful idea into a ghost story. The distinctions also reach down into the question of what you even are. If the loop is the closed circle, a single timeline bent into a ring, then there is exactly one of you, occurring once, on a road that happens to have no first or last point. If the loop is the exact repeat, there are endless copies of you, each identical, each living through this instant in turn. And if the loop is generative, then there is no other you at all, only the matter that currently composes you, going on to become parts of universes you will never be inside. These are not word games. They are genuinely different answers to whether your life is unique, repeated, or simply borrowed material in a longer story, and the phrase ends where it began conceals all three behind a single innocent sentence. Keeping them apart is the only way to think clearly about what comes next. Hold that idea close, because it returns at the end of our journey with much more weight than it has now. For the moment, simply notice that we have already loosened the line considerably. We have seen that its two ends are not clean edges, and we have seen that a line and a circle are impossible to tell, apart from the inside. But all of this has been intuition and geometry. None of it has been physics. It is time now to look at the single most precise and beautiful attempt anyone has made to show that the universe genuinely does end where it began. An idea built not on feeling, but on the hard mathematics of how our cosmos behaves at its two extremes. It comes from one of the most respected physicists of the last century, and it turns on a fact so strange that it sounds invented, even though it is not. Part 5. Penrose's Perfect Loop. The idea I want to show you now comes from Roger Penrose, a mathematician and physicist whose work on black holes and the structure of space and time placed him among the most important figures in modern physics. In 2010, he laid out, in a book called Cycles of Time, a proposal so audacious that many of his colleagues did not know what to make of it, and many still do not. He called it Conformal Cyclic Cosmology, which is a forbidding name for an idea that is, at its core, almost unbearably elegant. Penrose claimed that the cold, empty, dying far future of our universe is not the end of anything. It is, quite literally, the hot, dense beginning of the next universe, and he tried to show this not with poetry, but with geometry. To understand how he gets there, you have to follow one strange thread, and the thread is this. Penrose asks what the universe will actually contain in its extreme far future, after everything has run down. The stars will have burned out. The matter will have decayed or fallen into black holes. The black holes themselves, given long enough, will evaporate away through a slow leak of radiation until even they are gone. And what remains, at the very end, is almost entirely massless radiation, light and similar particles that have no mass at all. This matters more than it might seem, and the whole proposal turns on why. Here is the crucial fact. Particles with mass carry within them a kind of built-in clock and a built-in ruler. The mathematics of physics says that a massive particle has a natural frequency, a rhythm tied to its mass, and that rhythm lets the universe keep time and keep scale. But a massless particle, like a particle of light, has no such built-in clock. Light does not experience the passage of time at all. From the point of view of a particle of light, no time elapses between its creation and its absorption, however far it travels. And a particle with no clock also provides no ruler, no built-in standard of size or duration. So, in the far future, when the universe contains only massless radiation and nothing with mass, something extraordinary happens. There is nothing left in the universe capable of measuring size or distance or the passage of time. Now follow Penrose to his conclusion, because this is the moment the loop closes. If there is nothing left in the universe that can measure size, then the difference between enormous and tiny stops being a real physical difference. Size is a relationship. To say something is large, you need a ruler to compare it against. To say the universe is cold and spread out and immense, you need clocks and rulers to register the cold and the spreading and the immensity. Strip away every clock and every ruler, leave only massless light that cannot register scale at all, and the enormous, cold, dilute far future becomes mathematically indistinguishable from a tiny, hot, dense state, not similar to it, indistinguishable from it. And a tiny, hot, dense state is exactly the description of a Big Bang. The end of the universe, once you remove everything capable of telling you it is the end, simply is a beginning. Let me bring you all the way inside that moment, because it deserves to be felt and not just stated. You are standing in the last era of a universe. There is nothing here. The final black hole, the last structure that ever existed, finished evaporating a span of time ago so long that the words for it have lost all meaning. The last faint warmth has spread itself across an emptiness too large to hold a thought. A single ripple of light moves through the dark, and there is nothing for it to fall on, no eye to catch it, no clock anywhere to mark that it is moving, no ruler anywhere to say how far it has gone. Nothing here can tell large from small, because there is nothing here to do the telling. And in that very moment, with no jolt, no flash, no boundary crossed, no instant where one thing stops and another starts, the same scene that was the emptiest possible end becomes the fullest possible beginning. The dilute haze with nothing to measure, it reads, with equal truth as the white-hot density of a newborn cosmos. The end and the beginning are not two frames with a cut between them. They are one frame, read two ways, and the universe has slipped from its own death into its own birth without ever passing through a door. Much of what drove Penrose to this idea was a puzzle that had bothered him for decades, the strange orderliness of the beginning. The early universe was not just hot and dense. It was extraordinarily smooth and uniform, an exceptionally low entropy state, which is genuinely puzzling, because there are so many more ways for a universe to begin messy than to begin orderly. Why did ours begin in such a special, low disorder condition? Penrose's loop offers an answer. The orderly beginning is the smoothed out, scale-stripped remains of a previous aeon that had already run all the way to its own end, where expansion and evaporation had ironed everything flat. The very orderliness that makes our beginning so puzzling becomes, in his picture, exactly what you would expect if a beginning is really the polished end of the cycle before it. The low entropy start is not a mystery dropped on us from nowhere. It is an inheritance. It is fair to say that most physicists do not accept conformal cyclic cosmology, and Penrose knows this perfectly well. The proposal asks for things that are not established, including specific ideas about how mass fades from the universe in the far future, and whether the smooth rescaling he needs is something nature actually performs, rather than merely something the mathematics permits. These are serious objections, and we will sit with the broader problem of evidence later. But there is something worth admiring even in an unproven idea of this kind, which is the sheer nerve of it, the willingness to take the coldest, emptiest, most final state imaginable and insist that it is also the warmest, fullest, most initial one, and to back that insistence, not with mysticism but with geometry. Whether or not it turns out to be right, it is one of the boldest single ideas in modern cosmology, and it shows just how far the line can be bent by someone willing to follow the mathematics past the place where intuition begs them to stop. What makes Penrose's proposal so different from the ancient circle, and from a simple bounce, is that there is no violent moment of transition, no crunch, no singularity to pass through. The join between one universe and the next is smooth. It is what mathematicians call a conformal rescaling, a stretching or shrinking of size that leaves the underlying shape of things intact. Because the far future has no scale, you are free to rescale it however you like, and one particular rescaling turns the empty end into the dense, beginning with nothing lost and nothing forced. Penrose calls each full cycle an aeon, and in his picture the universe is an endless succession of aeons, each one ending in a scaleless emptiness that is identical to the fiery birth of the next. There is no first eon and no last. The line you were handed has, in his mathematics, closed into a circle after all, joined precisely at the place where you least expected it, the cold and final dark. It helps to notice exactly how Penrose's join differs from simply gluing the end of a movie to its beginning, because the difference is the whole elegance of it. He is not claiming that the universe runs down, stops, and then someone rewinds the tape. He is claiming that the run-down state, fully described, with nothing removed and nothing added, is already a description of a beginning, the way a single drawing can be a picture of a young woman or an old woman, depending on how you look at it, without a single line being changed. The far future does not turn into a big bang through some further event. It is a big bang read at the only scale that remains available once every ruler is gone. There is no moment of transformation to point to because nothing transforms. The same mathematics that describes the emptiest possible end is, without alteration, the mathematics of the densest possible beginning. The two descriptions are one description, and the join is not a seam but an identity. This is why Penrose insists the transition is smooth and physical rather than mystical. In the ordinary picture, the beginning and the end are separated by the entire history of a universe, with the singularity standing as an impassable barrier between any one cosmos and whatever might lie beyond it. Penrose dissolves the barrier not by tunneling through it, but by showing it was never a barrier in the first place, only a place where our scale-dependent description happened to break. Remove the dependence on scale, which the far future does for us by emptying itself of mass, and the barrier evaporates along with the rulers, leaving the end of one aeon resting directly against the beginning of the next with nothing in between. It is a join made of subtraction, achieved by taking away rather than adding, and that is what makes it so unlike every cruder picture of a universe that merely repeats. Part 6. When size stops meaning anything. I want to stay with the strangest piece of Penrose's idea, the piece that does the real work, because it is easy to nod along to the words, and much harder to actually let them change how you see things. The piece is this claim that size stops meaning anything when there is nothing left to measure with. It sounds at first like a wordplay, a clever trick, but it is not. It is pointing at something true and unsettling about the nature of size itself, something that was always hiding in plain sight, and once you see it, you cannot unsee it. Ask yourself a simple question. What does it actually mean to say that something is large? You might say, it means the thing is bigger than other things, and that is exactly right, and that is exactly the problem. Large is not a property a thing has all by itself, sitting alone in the dark. Large is a comparison. A grain of sand is enormous compared to an atom, and microscopic compared to a mountain, and it does not change at all in between. The same grain, the same object, is both large and small, depending entirely on what you set beside it. Size is not a thing an object carries inside itself. Size is a relationship between the object and a ruler, and without the ruler, the relationship simply does not exist. We never notice this because we are drowning in rulers. Everywhere you look, there is something to compare against. Your own body is a ruler. The room around you is a ruler. The atoms in the air, each one keeping its tiny built-in rhythm, are rulers. The universe you live in is absolutely saturated with mass, and every bit of that mass carries its little clock and its little standard of scale, so that size and duration are always defined, always available, always real. You have never once been in a situation where size was undefined, and so you have come to feel that size is simply a built-in fact about the world, an absolute, something that would still be true even if everything else was stripped away. But it would not. Take away every ruler, every clock, every massive particle that could register scale, and the question of whether the universe is large or small does not get a different answer. It stops having an answer at all. This is the realization I most want you to carry out of tonight, because it reaches far past Penrose's particular theory. The difference between an ending and a beginning, between a cosmos sprawled out cold across unthinkable distances and a cosmos crushed hot into a point, may not be a difference that is truly out there in the world. It may be a difference that exists only because we are here, full of mass, carrying our rulers and our clocks with us everywhere we go, insisting on measuring everything. We look at the dying universe and call it immense and final, and we look at the infant universe and call it tiny and initial, and we are sure these are opposite descriptions of opposite things. But the opposition might be something we bring to the scene rather than something we find in it. Remove the observer with the ruler, and the immense grave and the tiny cradle weigh exactly the same, because weighing itself has stopped. Sit with how strange that is. You have spent your whole life certain that big and small are real, fixed, absolute facts, as solid as anything you know. And here is a serious physical argument, saying that they are not absolute at all, that they are relationships requiring a measurer, and that in a universe emptied of measurers, the largest possible thing and the smallest possible thing become the same thing. The cold spread out end of everything and the hot crushed beginning of everything are, with no ruler to separate them, a single state. We thought the line ran from a small beginning to a large ending, but small and large were never permanent labels. They were just the readings on instruments that the universe will one day no longer contain. And when the instruments are gone, the two ends of the line are revealed to have been the same place, wearing different sizes, the way the same word can be spoken in two different tones. You can feel the same point in a smaller and more familiar way if you imagine a photograph of an object floating alone against a featureless background with nothing else in the frame. A picture of a marble against a blank white field and a picture of a planet against a blank black field can be made to look identical because with nothing around them to give a sense of scale, there is simply no way to tell how big the thing in the picture really is. We solve this in ordinary photographs by including something familiar, a hand, a coin, a person, a ruler, laid beside the object, precisely because size cannot be read off an object alone. It has to be read off a comparison. Now imagine a photograph with nothing in it at all to compare against. Anywhere, ever, not even the edge of the frame. That is the far future of the universe Penrose describes, a cosmos that is its own picture with every reference object removed, and in such a picture the words large and small have quietly lost their jobs. What this suggests, if you follow it all the way down, is something humbling about our role as observers. We are accustomed to thinking that we discover the universe, that we find the differences and the sizes and the structures that were already there waiting for us. But the difference between the universe's beginning and its end, on this view, may be partly something we contribute rather than something we find, because we arrive carrying rulers and clocks and insist on measuring everything we meet. A cosmos with no measurers in it does not experience itself as large or small, as beginning or ending, any more than a song with no one to hear it experiences itself as loud or soft. The measuring is ours. And if the measuring is ours, then perhaps the sharp line between birth and death that seems so absolute is, in part, a line we draw, standing where we happen to stand, with the instruments we happen to carry. None of this, I should say plainly, is settled science. Penrose's conformal cyclic cosmology is a serious proposal by a serious figure, but it is not confirmed, and many physicists have real objections to it, which we will come to honestly later. What I want you to take from it for now is not certainty, but a loosening, a sense that the most basic features of the line you were handed, even something as seemingly solid as the difference between its two ends, may rest on assumptions that do not hold all the way down. We have bent the line using Penrose's particular mathematics, but his is not the only road to a looping cosmos. There is another whole family of ideas that reaches the same destination by a completely different route, one that does not gently rescale the end into the beginning, but instead slams them together, and to those we turn next. Part 7. The Bounce. Penrose closes the loop by gently rescaling the end into the beginning, with no violence and no boundary crossed. But there is an older, and in some ways more intuitive way, to make the two ends of the line meet, and it does not whisper, it collides. This is the family of ideas known as bouncing cosmologies, and they start from a question that probably occurred to you somewhere back at the beginning of all this. If the universe began in a hot, dense state, what if that hot, dense state was not actually the start of everything, but the rebound from something that came before? What if the Big Bang was not a birth, but a bounce? The picture here is different from Penrose's. Instead of a universe that expands forever and then dissolves its own sense of scale, imagine a universe that expands, slows, and eventually reverses, falling back inward under its own gravity, contracting toward a hot, dense state once more. In the old version of this idea, that contraction would end in a crushing singularity, a great collapse that mirrored the great expansion, and the story would simply stop there, with no clear way to continue. But the modern bouncing models propose something else. They propose that the universe does not crush all the way down to a singularity and stop. Instead, at the moment of maximum density, it bounces, the contraction turning smoothly into a new expansion, so that the end of one cycle, the great collapse, becomes the beginning of the next cycle, a new Big Bang. The end and the beginning are joined not by rescaling, but by rebound. One influential version of this comes from what is called the ek-pyrotic model, developed in the early 2000s by Paul Steinhardt and Neil Turok, drawing on ideas from string theory. In their picture, our three-dimensional universe is something like a sheet, or a membrane, floating in a space with more dimensions than we can perceive, and there is another such sheet nearby. The two sheets approach each other across the extra dimension, and when they collide, the enormous energy released is what we experience as the Big Bang. Then they draw apart, and over an immense span of time the cycle resets, and they approach and collide again. Each collision is a beginning. Each beginning is the consequence of the previous cycle's slow approach to its end. In this model, there is no first collision and no last. The universe is eternal, and what we call the start of everything was simply the most recent time the sheets touched. A different route to a bounce comes from the attempt to apply quantum mechanics to gravity itself in a framework called loop quantum cosmology. The details are formidable, but the central result is beautiful in its simplicity. When you take the equations that describe the expanding universe and add the rules of quantum gravity, the singularity at the beginning, that place where the old equations gave infinities and broke down does not appear. In its place appears a bounce. Run the universe backward toward the Big Bang in these equations, and instead of hitting an infinite wall, you find that the universe was contracting before it was expanding, that it reached a minimum size, a state of enormous but finite density, and rebounded. The beginning of our expansion was the far side of a previous universe's collapse. The singularity, the question mark at the left end of the line, is replaced by a hinge connecting our universe to one that came before. It is worth noticing that both of these bouncing routes share a quiet appeal that has nothing to do with the equations. Each one removes the need for a single, unexplained first moment, the awkward instant where everything simply began for no prior reason. A universe that begins at a singularity invites the uncomfortable question of what set it off and why it started when it did, a question that has troubled thinkers for as long as there have been beginnings to wonder about. A universe that bounces sidesteps the question entirely, because there is no first moment to explain. Every beginning is the continuation of an end, every bang the rebound of a prior collapse, stretching back without limit. That does not make the bouncing models true, and a chain with no first link carries its own puzzles. but it does explain part of why so many physicists find them attractive. They trade the mystery of an absolute beginning for the milder strangeness of a process that has simply always been running. What strikes me about these bouncing models is that they reach the same shape as Penrose by a completely different path. Penrose joins the ends by removing scale until they merge. The bounce joins the ends by physical rebound, the collapse of one cycle becoming the expansion of the next. The mechanisms could hardly be more different. One is a quiet, smooth, scaleless slide. The other is a dramatic reversal at a moment of maximum density. And yet they arrive at the same conclusion, that the beginning of our universe was not truly a beginning, that the line extends past the left edge into something prior, and that the natural shape of cosmic history is not an arrow with two loose ends, but a cycle that comes around. And these are not the only routes. The point I want to make is not that any one of these models is proven, because none of them is, but that the loop keeps appearing. When physicists take our best theories and push them to the two ends of the line, again and again the ends refuse to stay loose. They want to connect. Penrose's rescaling, the ekpyrotic collision, the quantum bounce, each one a separate piece of mathematics built by different people for different reasons, and each one ending with the same picture, a beginning that is really a continuation, an end that is really a doorway. When an idea falls out of so many independent attempts, built on such different foundations, it stops feeling like a single person's pet theory and starts feeling like something the mathematics keeps trying to tell us. There is a genuine tension that bouncing models have to confront, and it is worth understanding because it shapes the whole debate. The arrow of time, that one-way growth of disorder we met earlier, does not obviously like cycles. If entropy only ever increases, then each cycle should inherit all the disorder of the cycle before it, and over many cycles the disorder would pile up without limit, so that the universe would look more and more worn out, the cycles growing longer and emptier, with no way to return cleanly to a fresh, orderly beginning. This was a famous objection to old cyclic models from nearly a century ago. The modern bouncing scenarios have to do real work to get around it, and they do so in clever ways. The ekpyrotic model, for instance, has the universe expand enormously during each cycle, diluting the accumulated disorder across an ever larger volume so that each new cycle begins effectively fresh, even though the total disorder keeps rising. The disorder is not erased. It is spread so thin that the next cycle does not feel it. What I find compelling about the bouncing picture is how it transforms the most intimidating object in cosmology, the singularity, from a full stop into a comma. For a long time, the singularity at the beginning was treated as an absolute wall, the place where questions had to end because physics itself ended there. The bounce says that wall may be an illusion created by using the wrong theory, general relativity alone, in a place where quantum effects dominate. Put the quantum rules in, and the wall becomes a bridge. Suddenly, the question of what came before the Big Bang, which sounds almost forbidden, becomes a sensible thing to ask. With a sensible answer, a previous universe contracting toward the bounce that became our expansion. The line does not start at the singularity. It passes through it, into a before, and that before may have had its own before, with no first link in the chain anywhere to be found. But there is yet another way the universe could end where it began, and this one does not require any special cosmology at all. It does not need rescaling, or colliding membranes, or quantum bounces. It needs only time, and a great deal of it, and a single result from physics that is over a century old. It is perhaps the most inevitable form of return there is, and it leads us into territory that is at once mathematically solid and almost impossible to feel. Part 8. The Eternal Return of Everything. There is a result in physics, proved in the late 19th century by the French mathematician Henri Poincaré that has a strange and haunting consequence when you apply it to the whole universe. The result is called the recurrence theorem, and in its plain form, it says something that sounds almost too simple to matter. Take any system that is finite and closed, meaning it has a limited amount of space and energy, and nothing leaks in or out. Let it evolve, let its parts move, and interact however they will. Poincaré proved that, given enough time, the system must return to a state arbitrarily close to the state it started in, not approximately, not usually, must. If you wait long enough, the configuration comes back. Think about what that means with a small example first. Imagine a sealed room with a handful of air molecules bouncing around inside it. At any moment, those molecules are in some particular arrangement, each one in some particular spot, moving in some particular direction. As time passes, they bounce and scatter through an enormous number of different arrangements. But the number of possible arrangements, while staggeringly large, is not infinite, because the room is finite and the energy is fixed. And so, if you wait long enough, the molecules must eventually wander back into an arrangement extremely close to the one they began in. Every molecule back near its starting spot, moving near its starting direction all at once, by pure chance, simply because, given enough time, the system explores its possibilities, and the starting arrangement is one of them. It will come back. It cannot do otherwise. Now scale that idea up carefully to the universe. If the universe is finite and closed, if it contains a limited amount of stuff in a limited space, then the same logic applies. The arrangement of every particle in the cosmos at this moment, the exact configuration that includes the stars where they are, the Earth where it is, this room, you, your exact arrangement of atoms in this exact instant, is one particular state out of an unthinkably large but finite set of possible states. And Poincaré's theorem says that if the universe goes on long enough, it must eventually return to a state arbitrarily close to this one. The cosmos would, given enough time, reassemble its own beginning and reassemble this very moment, not because it is on a circle and not because it bounces, but simply because a finite system that lasts forever must revisit everywhere it has been. Let me take you into that, because the scale of it is the whole experience. You are waiting inside a finite universe, and you have agreed to wait as long as it takes. The stars have long since died. The structures have come apart. The particles drift and scatter and recombine, shuffling through arrangement after arrangement in the dark. You watch configurations form and dissolve, clouds gathering and thinning, patterns that mean nothing assembling and falling apart, across spans of time so long that the entire current age of the universe would not register as the briefest flicker against them. You wait through a number of years you could not write down if you covered every surface in the cosmos with digits. And then, by no design, by nothing but the blind exhaustion of every other possibility, the particles drift into an arrangement you recognize. The same atoms, in the same places, moving the same ways. The room reassembles. The moment reassembles. You reassemble, here, exactly as you are now, having been scattered across an eternity and gathered back by chance alone. It was not a circle, and it was not a bounce. It was simply that, given forever, everything that can happen, happens, and then happens again. The recurrence times involved are beyond anything the human mind can hold. To give you a sense of it, physicists have estimated a recurrence time for a universe like ours, and the number is so large that it cannot be written in ordinary form. It is a tower of exponents, a 10 raised to a 10 raised to a 10 raised to a 10, a number whose number of digits itself has more digits than there are particles in the observable universe. These are not spans of time that will ever be experienced by anyone in any meaningful sense, but that is not really the point. The point is that the return is not impossible. It is not even unlikely, given enough time, it is guaranteed. In a finite universe that lasts forever, your exact present moment is not a one-time event that happens and is gone. It is a configuration that must recur, again and again, endlessly, separated by abysses of time, but certain to return. It is worth being careful about what the recurrence theorem does and does not promise, because it is easy to oversell. The theorem requires the universe to be finite and closed, with a limited number of possible states, and it requires it to keep evolving for an effectively endless span of time. Neither of those conditions is known to be true of our universe. If space is truly infinite, or if the accelerating expansion carries everything so far apart that the system never properly mixes again, then the guarantee weakens or fails entirely. So, recurrence is not a proven fact about our cosmos. It is a proven fact about a certain kind of system, which our cosmos may or may not turn out to be. What makes it worth taking seriously even so, is that, unlike most of the ideas we have met, it does not need any exotic new physics at all. It follows from counting, from the simple truth that a finite set of possibilities, explored endlessly, must eventually repeat. There is a darker cousin of recurrence that physicists genuinely worry about, and it sharpens the strangeness of the whole idea. In an eternal high disorder universe, random fluctuations can, very rarely, produce pockets of order by sheer chance, the way shuffled cards will occasionally fall into a brief accidental pattern. Given endless time, such fluctuations could in principle produce almost anything, including ordered regions that resemble young universes, or, more disturbingly, isolated patches of order just large enough to contain a single observer with a lifetime of false memories, flickering into being and dissolving again. This possibility is troubling enough that physicists treat any theory which predicts too many of these accidental observers as suspect, because it would mean a random fluctuation is a more likely explanation for you than the long ordinary history you remember. The mere fact that this has to be taken seriously tells you how strange eternity becomes once you accept that, given enough of it, everything that can assemble itself eventually will. Before we leave the idea of return, it is worth pausing on how differently it sits beside the arrow of time we began with. The arrow says, the universe runs one way, from order toward disorder, never repeating, and that is the deepest reason the future feels unlike the past. Recurrence does not deny the arrow within a single sweep of history. It simply says that if you wait long enough, far longer than the arrow's ordinary reach, the system can wander back to where it started, so that the one-way street turns out to be a one-way street drawn on the surface of a ring. You never walk backward. You only ever go forward, and forward, given enough of it, brings you home, which means the arrow and the circle are not enemies after all. The arrow describes the short walk, the circle describes the whole road. Both can be true at once, and holding them together is one of the stranger balancing acts this subject asks of us. This is the version of the loop that comes closest to Nietzsche's eternal recurrence, and it arrived in physics from a direction he never could have anticipated, out of the cold machinery of statistical mechanics, rather than the heat of philosophy. It says that if the universe is finite and endures, then not only does the beginning come back, but everything comes back, including this, including you, including the precise pattern of thoughts you are having as you listen. The line does not just close into a circle. The circle is travelled again and again without end. But notice that all of this rests on two conditions, that the universe is finite and that it lasts forever. And notice too that even if return is guaranteed, something crucial might still be lost across the immense gap between one occurrence and the next. To see what could be lost, we have to ask a question that sounds simple and turns out to be one of the deepest in all of this. When the universe comes back around, does anything remember? Part 9. The Scars of a Previous World. Every idea we have looked at so far shares a frustrating feature. It tells us the universe might end where it began, but it places the evidence somewhere we can never go, before our beginning, after our end, or across spans of time no one will ever witness. So, it is fair to ask whether any of this could ever be more than beautiful speculation. Is there any way, even in principle, that a previous cycle could leave a mark on ours, a fingerprint we could actually look for in the sky? Penrose thought there might be, and the search for that fingerprint is one of the most fascinating and contested episodes in modern cosmology. Here is the reasoning. If Penrose is right, and the cold, empty end of a previous eon became the hot, dense beginning of ours, then perhaps some information from that previous universe survived the transition. In particular, Penrose suggested that the most violent events of the previous aeon, the collisions and mergers of enormous black holes, would have released tremendous bursts of energy in the form of gravitational waves. If those signals could carry across the join from the old universe into the new one, they might have left faint, circular imprints on the oldest light we can see, the cosmic microwave background, the relic glow left over from shortly after our own Big Bang. The marks would appear as rings, regions where the temperature of that ancient light varies slightly less or in a slightly distinctive pattern than it does elsewhere. Concentric circles in the sky, the scars of black holes that died in a world before ours. In 2010, the same year his book appeared, Penrose, working with the physicist Vahe Gurzadyan, announced that they had found exactly this. Examining maps of the cosmic microwave background, they reported series of concentric rings, where the variation in the ancient light seemed unusually low, just the sort of pattern they had predicted. Later, the claim was refined and extended to features that became known as Hawking points, small patches that might represent the final evaporation of an enormous black hole from the previous aeon, its lifetime of radiation arriving as a concentrated spot in our sky. If these claims held up, they would be among the most extraordinary discoveries in the history of science, direct observational evidence that our universe had a predecessor, that the line really does extend backward past our beginning into a world that came before. But I have to be honest with you about where this stands, because honesty is the whole point of how this channel treats ideas like these. The claims are not accepted. When other research groups examined the same data, most concluded that the rings and points Penrose and Gurzadyan had found were not genuine signals from a previous universe. They argued that features like these appear naturally in a random sky, that if you look for circular patterns in a noisy map, you will find some by chance, and that when you compare the real sky to simulated skies with no previous eon at all, the simulated skies show similar features just as often. The disagreement has gone back and forth in the technical literature, with claims and rebuttals, and the weight of opinion has settled against the interpretation that these are scars of a previous world. The features may be real patterns in the data, but the leading explanation is that they are the ordinary statistics of randomness and the artifacts of how the data is processed, not messages from before the beginning. I do not tell you this to deflate the idea, but because the actual situation is more interesting than a tidy triumph would be. Here is a serious physicist making a falsifiable prediction that a cyclic universe should leave specific marks in the sky and then going and looking for those marks. That is exactly how science is supposed to work, and it is to Penrose's enormous credit that his version of the loop makes a prediction concrete enough to be tested at all. When so many cosmological ideas float forever, beyond the reach of any observation, the test was run. So far, the evidence has not supported the claim. That is not a failure of the method. It is the method working, and it leaves the door neither slammed shut nor thrown open, but standing exactly where the honest evidence places it, ajar and uncertain. It is worth saying a little more about the cosmic microwave background, because it is the closest thing we have to a baby picture of the universe, and it is the natural place to look for any fingerprint of a previous one. About 380,000 years after the Big Bang, the universe had cooled just enough for atoms to form and for light to travel freely for the first time, and that ancient light has been streaming through space ever since, stretched by the expansion into a faint glow of microwaves that fills the whole sky. We have mapped it with extraordinary precision, and it is astonishingly uniform, the same temperature in every direction to within tiny fractions of a degree. The minute variations in that glow encode the seeds from which all later structure grew. If anything from before our beginning could leave a mark, we could read, "This oldest light is where it would most plausibly be written," which is exactly why Penrose and Gurzadian went looking there rather than anywhere else. The episode is a small lesson in how science actually treats extraordinary claims, and it is worth holding up against the way such claims are often imagined to be handled. There was no suppression, no committee burying an inconvenient result. The claim was published, examined by anyone who cared to look, tested against the same data and against simulated skies, and found wanting by most of the people who checked. The disagreement played out in the open, in papers and rebuttals, over years. That is not a system protecting a comfortable story. It is a system doing precisely what it is supposed to do with a bold idea, which is to take it seriously enough to test it and to be honest enough to report when the test does not support it. The loop survived this particular test only in the sense that it was not killed by it, because the failure to find the rings does not prove there was no previous aeon. It only means that, if there was one, it did not leave the mark we hoped to find. And there is a quieter lesson buried in this episode, one that points toward the next turn in our journey. Even in the best case, even if some signal had survived, notice how faint and how nearly erased it would have to be. A previous universe, in Penrose's own picture, hands almost nothing to the next. It passes along its scale, and perhaps the ghostliest tremor of its most violent events, and otherwise it is gone, wiped clean in the transition, its stars and worlds and whatever lived in them, leaving no inventory behind. Which raises the question that has been waiting patiently underneath all of these models, the question of memory. If the universe truly ends where it began and begins again, what carries across? Does the new cycle know anything at all about the old one? And if the answer is nothing, if each beginning starts perfectly fresh, then we have to ask what it even means to call it a return. Part 10. The Problem of Memory. We have spent this whole journey treating return as the remarkable thing, the universe coming back to its beginning, the line closing into a circle. But there is a problem hiding inside the word return, and it is time to bring it into the light, because it changes the meaning of everything we have said. The problem is memory. When something returns, we usually mean that it comes back carrying some trace of where it has been. But what if the universe comes back to its beginning, carrying nothing at all, no record, no trace, no faintest residue of the cycle that came before? Is that still a return? Or is it just a new beginning that happens to resemble an old one, with no thread connecting them? Consider what each of our models actually says about this. In Penrose's Conformal Cyclic Cosmology, the transition from one aeon to the next deliberately strips away nearly everything. The whole mechanism depends on reaching a state with no scale, no clocks, no rulers, which means no structure, no information about stars or galaxies or histories, almost nothing of what the old universe contained. The new eon does not inherit the old one's contents. It inherits only the bare scaleless state and begins fresh. In the bouncing models, there is at least the possibility that some information survives the bounce, but many versions involve such extreme conditions at the moment of rebound that the details of the previous cycle are scrambled beyond any recovery. And in loop quantum cosmology, there is a haunting phrase for this very issue. Some physicists call it cosmic forgetfulness, the idea that the bounce so thoroughly blurs the bridge between the old universe and the new that the new universe cannot, even in principle, reconstruct what the old one was like. It is worth dwelling on how strange this makes the whole notion of evidence across a cycle. We usually imagine that if something really happened, it must have left some trace, however faint, somewhere. A footprint, a scar, a record, a memory. The forgetting at the core of these models breaks that assumption completely. A previous universe could have been every bit as real as this one, filled with its own stars and worlds, and perhaps its own watchers, and yet hand absolutely nothing forward, not a single recoverable fact about itself. Its entire history would be not hidden, not lost, but erased in the most thorough sense possible, leaving a new universe that begins as if nothing had ever come before. And if that is what a cycle does, then the question of whether there was a previous universe stops being something we could ever settle by looking, because looking depends on traces, and a perfect forgetting leaves none. The past, on this picture, does not recede out of view, it is unmade. This forces a strange and uncomfortable question. If a cycle erases all memory of the cycle before it, then from inside any given cycle, you cannot tell whether you are the first or the billionth. There is no marker. There is no worn place on the wheel that says you have been here before. Each cycle begins as cleanly and as freshly as if it were the only one that had ever been, because the very mechanism that connects the cycles is the mechanism that erases the connection. The loop, if it exists, is a loop with no memory of being a loop, which means that being on an enormous wheel turning for the 10 billionth time and being on a brand new line running for the very first time would feel, from the inside, precisely identical. There would be no experiment you could run, no measurement you could take that would distinguish them. Let me bring that all the way down to where you are sitting, because it is not as abstract as it sounds. Right now, this moment you are living, could be the first time it has ever occurred in the history of existence, a genuinely new event in a universe running once. Or it could be a moment that has already happened an unthinkable number of times before, in cycle after cycle, each one having reached this exact configuration, this exact room, this exact instant, and then forgotten it and reached it again. And here is the part that should make the floor tilt. From inside the moment, you cannot tell which. The two situations, perfect uniqueness and infinite repetition, do not feel different. They cannot feel different because anything that would let you feel the difference, any memory of the previous time, is exactly what the loop erases. You are either having this thought for the first and only time or for the 10 billionth time, and the experience is exactly the same either way. This is one of the most genuinely vertiginous consequences of taking the loop seriously, and I want you to notice how it inverts everything we usually feel about uniqueness and repetition. We tend to think of a unique, once-only moment as precious, and an endlessly repeated moment as somehow cheapened, drained of meaning by recurrence. But if uniqueness and infinite repetition are truly indistinguishable from the inside, then that whole intuition collapses. The preciousness we feel in a moment cannot depend on whether it has happened before, because we cannot know whether it has happened before, and the moment feels exactly as precious either way. The weight of this instant, whatever weight it has, comes entirely from inside it, not from its place in some larger count we can never access. A first time and a 10 billionth time weigh exactly the same, because there is nothing left to measure the difference with. This problem of memory connects to a much older puzzle about identity, the question of what makes something the same thing when everything about it has changed. Thinkers have asked for thousands of years whether a ship that has had every plank gradually replaced is still the same ship, and the question bites hardest exactly when no physical continuity remains. A cosmic cycle that hands nothing across the join, no matter, no structure, no record, is the most extreme version of this puzzle imaginable. If the next universe shares no atoms, no events, no memory with this one, in what sense is it a return at all, rather than simply a different universe that happens to come after? The honest answer is that the word return may be doing more work than the physics can support. What loops, in the generative models, is not a thing but a pattern, the bare fact that an end gives rise to a beginning, and whether you call that a return or merely a succession is partly a choice about words. And yet, there is a strange kind of comfort hidden in the forgetting if you look at it gently. A loop with perfect memory would be a heavy thing to carry, every cycle weighed down by the accumulated record of all the cycles before, every beginning shadowed by an endless history of identical beginnings. The forgetting, whatever else it costs, means that each cycle, if there is more than one, gets to be genuinely fresh, opening as cleanly as if it were the first and only one. There is no inherited fatigue, no sense of having done all this before, because the doing before left no trace that anyone inside could feel. Whether that is a mercy or a loss depends entirely on what you would want, and that, it turns out, is not a question physics can answer for you. It is a question about how you would choose to feel about a wheel you can never see and can never step off. And we are about to meet the man who asked it most fiercely. You may notice that phrase, coming back, nothing left to measure the difference with, and that is not an accident. It is the same idea that closed Penrose's loop, the same idea that dissolved the difference between the largest thing and the smallest thing now turned around and pointed at you. When the universe ran out of rulers, its end and its beginning became the same. When a cycle runs out of memory, its first occurrence and its 10 billionth become the same. In both cases, a difference we were certain was real turns out to require an instrument that is not there, and once the instrument is gone, the difference quietly goes with it. We started by asking whether the universe ends where it began. We are arriving somewhere, stranger, at the discovery that the question keeps dissolving the very distinctions we tried to use to ask it. And that brings us, at last, to the most personal turn of all, the one Nietzsche saw coming more than a century before the physics caught up. Part 11. Are you in the loop? For most of this journey, we have kept the loop at a safe distance, out among the aeons and the recurrence times and the maps of ancient light. But every version of the idea, if you let it, eventually walks back across all that distance and sits down beside you, because if the universe ends where it began, then so, in some sense, do you. You are made of the universe's matter. You are a particular arrangement of it, holding together for a short while. And, if that matter returns to its beginning, if this exact configuration must recur, then the question stops being about cosmology and becomes about your own life, the one you are living right now, in this room, in this moment. Nietzsche understood this with a clarity that still unsettles, and he posed it not as a theory but as a kind of test. Picture the scene the way he framed it. It is the loneliest hour of the night, the hour when you are most honestly yourself, and something comes to you, call it a demon, and speaks. This life as you now live it, and have lived it, it says, you will have to live once more, and innumerable times more, and there will be nothing new in it. Every pain and every joy, and every thought, and every sigh, everything unspeakably small or great in your life, must return to you, all in the same succession and sequence. This same moment, the two of you here in the dark, the demon speaking and you listening, returns as well, again and again, forever. And then it asks you the only question that matters. Would you fall down and curse the demon who spoke this way? Or would there be a moment in which you could answer, never have I heard anything more divine? Sit in the room with that question, because it is the hinge of everything. Nietzsche was not, in that passage, claiming that the universe is literally a loop. He was using the possibility as a mirror, a way of asking how you are living. If you had to live this exact life over and over without end, would the thought crush you under its weight, or would it set you free? He believed the question was the most demanding test a person could face, because it strips away every comfort that depends on things being temporary. You cannot tell yourself that the bad parts will at least be over, that the regret will fade because it happened only once. On the loop, nothing is only once. Everything you do forever. What gives this its strange new force is that the physics we have walked through tonight makes the mirror more than a metaphor. If the universe is finite and endures, Poincare's theorem says this exact configuration must recur, which means this exact moment must recur, which means Nietzsche's demon may simply be reporting a fact. Not a certain fact, because we do not know that the universe is finite, and we do not know that it endures forever, and the conditions may not hold, but a possible fact, sitting inside the mathematics, no longer purely a thought experiment. The most personal version of the loop is also the most testable in principle and the most impossible to escape if it is true, because you are not an observer of this loop. You are one of the things on it. And here the earlier discovery about memory returns to do its quiet work. If the loop erases all memory between cycles, then you will never know whether you have lived this life before. You will never feel the wheel turn. Each time, if there is more than one time, will be the first time as far as you can ever tell. Which means the demon's question is not really about cosmology after all. It is about now. It is about whether this moment, taken entirely on its own, without any appeal to whether it repeats or whether it is unique, is something you can affirm. Because the repetition, if it exists, adds nothing you can feel, and the uniqueness, if that is the truth instead, takes nothing away that you can feel. Either way, all the weight falls on the moment itself, on this one, the only one you will ever actually have access to, regardless of how many times it does or does not return. What Nietzsche did with that question was turn a cosmological possibility into a kind of mirror you cannot look away from. He was not trying to prove that time is a circle. He was using the image of the circle to measure the quality of a life. If the thought of living your life again, exactly, forever, fills you with dread, then perhaps that is telling you something about how you are living it now. And if there could be even a single moment so complete that you would willingly have it return without end, then you have touched something he believed most people never reach. He gave a name, elsewhere, to the attitude he was reaching for, a love of one's fate, a willingness not merely to endure what happens, but to affirm it so fully that you would choose it again. The eternal return was his test for whether a person had arrived at that, and the test works whether or not the universe actually loops, because the demon is really just asking you what your life is worth to you. The physics we have walked through gives that old question an edge it did not have in his time. Nietzsche could only pose the recurrence as a hypothetical, a thought to wield against himself and his readers. But we have seen that real mathematics, the recurrence theorem applied to a finite and enduring universe, can turn the hypothetical into a genuine physical possibility, not certain, but not absurd either. That changes the texture of the question. It is one thing to imagine living this moment again as a philosopher's device. It is another to sit with the possibility that the equations themselves may permit it, that somewhere in the structure of a finite cosmos, this exact configuration is not a one-time accident, but a recurring feature, returning across spans of time too large to name. The demon, it turns out, may have had a point that goes past philosophy and reaches into physics, and either way the question it leaves you with is the same, and it is waiting for you tonight. That, I think, is the gift hidden inside the most vertiginous version of the loop. It hands you back your own present, undivided, and tells you that its value cannot be borrowed from some larger story about cycles and counts, because you can never reach that larger story. The weight of your life is in your life. The loop, whether it turns once or forever, cannot add to that weight or subtract from it. And so the cosmic question and the human question turn out to be the same question asked at two scales. Does the universe end where it began? And if it does, and you can never tell, then what will you do with the one turn of it you are awake for? Part 12. Why we may never know. We have followed the loop through ancient symbols and modern mathematics, through rescaling and bouncing and recurrence, through the search for scars in the sky, and the strange problem of memory and the demon at the bedside. And now we have to face, squarely and without flinching, the hardest truth of all, which is that we may never be able to find out whether any of it is real. The universe may genuinely end where it began, and we may be permanently unable to confirm it, not because we lack cleverness or better instruments, but because of where we are standing. Think about what it would take to actually verify the loop. You would need to see past the beginning to whatever came before our Big Bang and check whether the line connects to something prior. But we cannot see past the beginning. The earliest light we can detect, the cosmic microwave background, comes from a time after the Big Bang, and before that the universe was opaque, a fog through which no light could travel. There is a wall behind us, in time, that no telescope can see through. Or you would need to see all the way to the end, to whatever the far future becomes, and check whether it slides into a new beginning. But we cannot see the end either. It lies an unthinkable span of time ahead, far beyond not just our lives, but the life of our species, our planet, our star. We are sealed inside a small, bright stretch of the timeline, with the beginning hidden behind one wall and the end hidden behind another, asked to determine the shape of the whole road from a single short segment of it. And we already know, from much earlier in our journey, exactly why that is hopeless. Remember the walk along the road that felt straight the entire time and yet delivered you back to your starting point. A circle large enough is locally indistinguishable from a line. Stand anywhere on it, look at the stretch near your feet, and a line and a circle give you precisely the same view. To tell them apart, you would have to step outside and see the whole shape at once, and with time, you cannot step outside. You are always somewhere on the road, always seeing only the straight-looking piece near your own moment. So the very feature that makes the loop so beautiful, that it would feel exactly like a line from the inside, is also the feature that makes it so nearly impossible to detect. The loop hides itself perfectly, not by being far away, but by being the thing you are standing on. There is an old image for this that we met near the beginning, the serpent that swallows its own tail, and it turns out to be even more apt than it first seemed. We used it then as a picture of looped time, a beginning and an end, fused into one. But look at it again now, with everything we have learned. The reason you cannot find where a snake eating its own tail begins is not that the beginning is hidden somewhere clever. It is that there is no loose end anywhere to grab. The figure offers you nothing to take hold of, no edge, no starting thread, no place to begin unwinding it. That is exactly our situation with a looping cosmos. We are not failing to find the loose end of time because we have not looked hard enough. We may be failing because, if time is a circle, there is no loose end to find, anywhere, by anyone, ever. The Ouroboros is not just a symbol of the loop, it is a symbol of why the loop cannot be caught. There is something almost vertiginous in realizing that the difficulty is not practical but structural. We are used to mysteries that yield to effort, where a sharper telescope or a cleverer experiment eventually pulls back the curtain. This is not that kind of mystery. If time is a circle, the reason we cannot find its beginning is the same reason a person walking on the surface of an enormous sphere cannot find its edge, not because the edge is far away or well hidden, but because there is no edge to find. The search fails not from weakness, but from the nature of the thing being searched for. And a search that is guaranteed to fail, no matter how well it is conducted, is a strange thing to build a science around, which is exactly the discomfort that the loop forces us to sit with. You can sharpen that discomfort with a simple thought. Suppose two universes, identical in every observable respect, one of them genuinely a closed loop, and the other a one-time line that merely happens to look the same from inside. Every measurement anyone could make in either universe would come out identical. Every experiment would agree. There is no instrument, no observation, no clever test that could ever distinguish the looped universe from the linear one, because the difference between them lies entirely in features no observer inside either could ever reach. When two pictures of the world predict exactly the same observations forever, science has no tool that can choose between them, and the choice, if it is to be made at all, falls to something other than evidence, to taste, to elegance, to philosophy, or to nothing at all. I want to be careful and fair here, because this unprovability is also the strongest objection to the whole family of ideas, and it deserves to be stated plainly. A scientific idea earns its standing by making predictions that could in principle fail, that expose it to being proven wrong. Penrose's version reached admirably for that standard, with its rings in the sky, and so far the evidence has not supported it. But many forms of the loop predict a universe that looks, from the inside, exactly like a universe with no loop at all. And an idea that predicts the same observations, whether it is true or false, is an idea that science struggles to get any grip on. This does not make the loop wrong. Reality is under no obligation to be conveniently testable, but it does mean we should hold these ideas with a particular kind of honesty, as genuine possibilities permitted by real physics, openly studied by serious people, and at the same time as possibilities that may sit forever just beyond the edge of what we can confirm. It is worth being precise about the walls that box us in, because each one is real, and each one is, as far as we can tell, permanent. Behind us in time stands the wall of the early opaque universe, beyond which no light can carry information to us, sealing off the first few 100,000 years and the beginning itself. Around us in space stands another wall, the cosmic horizon, the distance beyond which the expansion of space carries objects away so fast that their light can never reach us, hiding forever whatever lies past it. And ahead of us, in time, stands the longest wall of all, the simple fact that the far future where the loop would close lies unimaginably beyond the lifetime of our species, our planet, and our star, so that no human will ever stand at the end to watch whether it becomes a beginning. We are not boxed in by ignorance that better instruments could cure. We are boxed in by the structure of the universe itself. I want to be careful that none of this curdles into a kind of defeatism, because that is not the spirit of it. To say that a question may be beyond our reach is not to say that asking it was a mistake, or that the answers people propose are worthless. The value of these ideas is not only in whether we can confirm them, it is in what they reveal about the assumptions we did not know we were making, about size, about time, about the difference between an ending and a beginning. Even if we never learn whether the universe literally loops, we have learned, by taking the possibility seriously, that the line we were so sure of rests on foundations softer than we believed. That is real knowledge, even when the headline question stays open. A clarified mystery is worth more than a false certainty, and it is a great deal more honest, which is the only currency worth dealing in when the walls are this high and this permanent. So we arrive, as we so often do on this channel, not at an answer but at a clarified mystery, which is a better thing to have than a false answer. We cannot say whether the universe ends where it began. We can say that several independent strands of our best physics suggest it might, that the idea is as old as human thought and as new as the latest equations, and that if it is true in a way we are unusually badly placed to ever verify. That might sound like a disappointment. I think it is closer to a kind of peace. Because what we are left with, when the grand question turns out to be unreachable, is the road right here, under our feet, the only part of the circle, or the line, that we will ever actually get to walk. Part 13. The Circle and the Line. At the very start of tonight, I said that you were handed a picture of time long ago, and that the picture was a line with a beginning on one side and an end on the other, and all of cosmic history stretched out between them like towns along a single straight highway. I asked if we could take that line gently out of your hands and turn it over, and we have spent these hours doing exactly that. So let me put it back in your hands now and let you see what has happened to it along the way. The line you were handed had two ends, and we went to look at both of them, and we found that neither one was a clean edge. The beginning dissolved into a singularity, a place where our physics throws up its hands and admits it cannot describe what is there. The end dissolved into a scaleless quiet, a place with no clocks and no rulers, where the very idea of size and duration stops meaning anything. The two ends that seemed most opposite, the hot, crowded birth and the cold, empty death, turned out to share the one feature that mattered, that at both of them the ordinary machinery of time gives out. And then, idea by idea, we watched physicists try to join those two ends. Penrose joined them by removing every ruler until the largest thing and the smallest thing became the same thing. The bouncing models joined them by rebound, the collapse of one cycle becoming the birth of the next. Recurrence joined them by sheer endurance, a finite universe certain to wander back to its own beginning, if only it lasts long enough. None of these is proven. I have tried to be honest about that at every turn, because the honesty is the point. The rings Penrose looked for in the sky have not held up. The unprovability of the loop is its deepest weakness, as well as its strangest beauty. We do not know whether the universe ends where it began, but notice what has happened to the line anyway, just from looking at it this carefully. It no longer sits comfortably straight in your hands. Its ends have softened and curled. The certainty that the beginning and the end are two different places, as far apart as two things can be, has quietly drained away, replaced by a real and serious possibility that they are the same place, wearing different sizes, the same moment, read in two tones. The line you were handed has, at the very least, begun to bend, and here is the thought I want to leave you with in the last quiet stretch before you drift off. Whether or not the universe is literally a circle, something true has been revealed about the line, which is that its two most basic features, the difference between its beginning and its end, the difference between its largest state and its smallest, the difference even between a first time and a 10 billionth time, all of these turned out to depend on having something to measure them with. Remove the rulers, remove the clocks, remove the memory, and the differences do not get smaller. They vanish. When there is nothing left to measure with, an end and a beginning weigh exactly the same. That is not a fact about one particular theory of cosmology. That is a fact about the nature of difference itself, and it was hiding inside the comfortable line the whole time. Let me gather the whole journey into a single image before we let it go. We began with a line handed to you in childhood, straight and certain, a beginning on one side and an end on the other, as far apart as two things could be. We walked to both of its ends and found them soft, dissolving, not the clean edges we had been promised. We remembered that humans drew the circle long before they drew the line, and then watched the circle return, unbidden, out of the newest mathematics, through Penrose's scaleless rescaling, through the rebound of bouncing universes, through the patient certainty of recurrence. We looked for the loop's fingerprint in the oldest light and did not find it. We discovered that a loop with no memory and a line with no repeat would feel exactly the same from inside, and that uniqueness and endless return weigh the same when there is nothing left to measure the difference with. And through all of it ran one quiet discovery that does not depend on which theory, if any, turns out to be true. The differences we trust most, between large and small, between beginning and end, between the first time and the countless time, are not carved into the world as absolutes. They are relationships, and relationships need something to hold them up. A ruler, a clock, a memory. Take those supports away, as the universe one day will, and the differences do not shrink. They simply stop being there. That is the real gift of sitting with a question like this one. Not an answer about the shape of time, which we may never possess, but a loosening of our grip on certainties we never knew we were clutching. The universe may or may not end where it began. What is certain is that the line you were handed was never quite as straight as it looked, so you can keep the line if you like. It will serve you perfectly well for living, the same way a flat map serves you perfectly well for walking across a city, even though the earth is curved. From where you stand, the line and the circle are identical, and they will stay identical no matter how long you walk, because you can never rise above the road to see its shape. But you might hold the line a little more lightly now, knowing what you know. You might carry, somewhere in the back of your mind, as you fall asleep, the quiet possibility that the road you are on bends so gently you will never feel it, that the moment of your beginning and the moment of all endings are joined somewhere out, past every wall you cannot see through, and that the universe, for all its long travel, may end exactly where it began. We cannot prove it. We may never prove it. But the snake has its tail in its mouth, and there is no loose end anywhere to say that it does not.